Hey everybody, I just wanted to give a quick summary of the substitution and elimination chart I put up on the website. As well, if you can see the chart, we have it's a combination of 4 columns and 4 rows. And so in the rows, we have the 4 different types of nucleophilic and basic strength conditions. We have strong, 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 weak, weak, strong, and weak, weak. We've covered these in class, what they are. And then in the 4 columns, we have the different types of substitutions on carbons that the leaving group is attached to. So we have methyl, primary, secondary, and tertiary. So this chart was really helpful for me to get through my organic chemistry course, so I think it'd be really helpful for you guys as well. And so, as I mentioned, I'll go down each column and explain what happens with each reaction. So, for our methyl column, we start with strong, strong. Um, we'll have an SN2 mechanism, and then for strong weak, we will also have an SN2 mechanism. These methyl carbons are really easy to attack, and so if we have a strong nucleophile, we'll be able to do an SN2 mechanism. But if we have a weak strong or a weak weak, those guys aren't strong enough to do the SN2 mechanism, and so we have no reaction for the methyl carbons with weak strong or weak weak. So now onto the primary carbon column. For the strong strong and strong weak, we have the SN2 mechanism occurring again because these reactions, these strong nucleophiles are able to attack the carbon even though there is the primary carbon. They're still able to get and do that backside attack. With the weak strong conditions on a primary carbon, we'll actually have an E2 mechanism occur because the weak strong will be able to pull off a hydrogen on the neighboring carbon, and this is a nice with this primary carbon, it's a nice stabilizing condition for the carbocation, allowing for the E2 reaction mechanism to occur. But if we have a primary carbon in a weak situation, there'll be no reaction. And so for the third column, we have a secondary carbon that the leaving group is attached to. For a strong conditions, we will have an E2 reaction mechanism occur, but for strong weak, we'll have an SN2 reaction mechanism occur. And then for weak strong, we will have an E2 reaction mechanism occur. And for weak weak, we'll have about 50-50 SN1 E1 conditions, and as we've discussed before, which condition they're usually about 50-50, but certain conditions can shift it to SN1 or E1. And then lastly, we have the tertiary carbon, so that has the leaving group and 3 substituents coming off of the carbon. In strong conditions, we will have an E2 reaction mechanism because this tertiary carbon is great at stabilizing carbocations. For strong weak, we will have no reaction mechanism, and for weak strong, we will then have E2 reaction mechanism, and for weak weak, we will have SN1 or E1, like I said before, depending on the conditions. So use this chart to really help you guys out. You can see if we have if you look at the chart when we look at methyl versus primary, we see a lot more SN2 reaction mechanisms, but once we get into secondary and tertiary carbons, we get a lot more E2, SN1, and E1 reaction mechanisms, and that has all to do with the substituents on the carbon. So hopefully this will help you guys out. This chart really helped me out in my organic chemistry course, so hopefully it'll help you out too. Thanks.